This is section 8.3, part 2. It has to do with working with the formulas for area of circles and area of regular polygons. So we're going to go through 3 examples. The first example says a small apple pie has a diameter of 8 inches, which means that its radius would be 4 inches. And the large cherry pie has a radius of 5 inches. And just for fun, it has a diameter of 10 inches. So they were trying to trick us by talking about one of them in terms of diameter and the other in terms of the radius. How much larger is the large pie? Okay, we'll start with the large pie. The area is pi r squared. So that's pi times the radius of 5 squared. So it would be pi times 25. And when I put that in my calculator, it's 78.5. The small pi is also a circle, so its area is pi r squared. Its radius is 4. So that 4 squared is 16. When I put that into my calculator, it's 50.2. So how much larger is the large pi? The large pi was 78.5. If I subtract the small pi of 50.2, I get 28.3, and these are in inches, and its area, so it'd be square inches. So that is the first example. And here it is worked out again. Okay, here's the next one. If the area of the circle at the right is 256 pi square meters, what is the circumference of the circle? Well, they're asking for the circumference. So I'm going to say circumference is equal to 2 pi r. Okay, circumference is equal to 2 times pi times the radius. They're not telling me the radius here. They're telling me what the area is. So I'm going to back up. So when I back up, I'm going to go over here and say, they're telling me the area, which is pi r squared in a circle. And they're telling me that the area is 256 pi. So that has to equal pi r squared. If I divide this side by pi and this side by pi, the pi's cancel out, and I have r squared is equal to 256. To get r alone, I have to get rid of that square, so I square root both sides. The square root of r squared is square root of r times r. Those two r's come out as an r. And 256, the square root of that, since it's 16 times 16, the two 16s would come out as a 16. So now I can come over here and put that in as my radius. So now this is going to be 32 pi, and if I put that into my calculator, it would be 100.5 meters. Okay, so 32 pi or meters or 100.5 meters would be my answer to problem B. Okay, problem C. 2 people, Jeannie and Ray, are planning to build a foam safety ring that will surround the family trampoline for their 2 kids, Casey and Ginger. The outside perimeter is a regular dodecagon that has 12 sides. So I know then, if these are regular polygons, I know the area of a parallelogram of a regular polygon is 1/2 SAN. So I have to know S and A and N for both of these. So why don't I make a list here? It's right over here. For the dodecagon, I just found out that I need an S, an A, and an N. So it's a dodecagon, so that tells me that N is 12. And it says each side measures approximately 7. That's S, the length of each side. Okay, The inner is a regular octagon. So I need S and A and N for the octagon. An octagon has 8 sides, so N is equal to 8. It says each side measures approximately 8.2. Okay. Then I continue on. The approximate length of the apothem of the dodecagon is 13, and the approximate length of the apothem of the octagon is 10. So I have all the values that I need, and they ask what is the approximate area they will need to cover in foam. So this is the part here that they're going to cover in foam. So what I'm going to do is take the area of the outer dodecagon, and I'm going to subtract the area of the inner octagon. So here is where they do this. The dodecagon, they have 1/2 ASN. I usually do SAN. They have ASN, no big deal. So 1/2 stays 1/2. The apothem was 13. S is the length of the side, that was 7. And the number of sides in a dodecagon is 12. When you multiply that out, it gets to be 546, and its area, so be square feet. In the octagon, here's 1/2. The apothem was a 10. The length of a side was 8.2, and the number of sides was 8. When you multiply that, you get 328. So the area of the foam ring would be taking the entire dodecagon and subtracting out the inner octagon, and then what would be left would be the edge of 218 square feet. So those are 3 examples that show the use of our formulas for the area of a circle and the area of a regular polygon.